Hi, ladies and gentlemen. We're going to do 8.4 today, problem solving with trigonometry. And this is going to be our final trigonometry lesson. And then we're going to be moving on to quadratics next. Before we get into the problem solving, I just want to construct a little flowchart with you so we can determine when we use our different formulas. So first of all, the first question we always ask ourselves is it a right triangle? Right triangle. And if the answer is yes, then we use our SOHCAHTOA. If the answer is no, then we're looking at a sine or a cosine law. So, do we have a pair of data or info? And what I mean by that is, do we have a pair here? So if this is 50 and this is 8 centimeters, when you have both the angle and the opposite side, that's a pair. So if we have that, and let's say another side, then we can solve for this angle. So that would be the sine law. And so here we can solve for the angle. We can also do the same thing. If we have A and A, we have a pair here. We can also use that if we know this length, or sorry, if we know this angle here, let's call it 50 as well, then we can solve for this angle as well. So those are the sine laws, and we know the sine law looks something like this. And if we don't have a pair of the info, then we're going to go with our cosine law. So that's where we have a triangle and we know two sides and we know the contained angle, and we can use that to find the opposite side. Or in another situation here, we know all three sides. We can use that to find the missing angle. And of course our formula is here. This is our a squared, assuming this is a and we're trying to find a. A squared is equal to b squared plus c squared minus 2ac cosine a. And for this one here, we use our, so that's side A and angle A. If we're trying to find angle A, we use our reworked formula, which we learned last day. Something like that. So a little bit of a flow chart. If it's right angle, SOHCAHTOA. If it's not, we're gonna look toward our sine law. If our sine law doesn't work because we don't have this pair of information or pair of data, so to speak, then we're going to go to our cosine law. And depending on if we're trying to find a side length, we use our cosine law. If we're trying to find an angle, then we use the reworked formula. So hopefully that helps you out a little bit. All right, so we have a couple other questions here in the notes that I forwarded to you. So in example number 1, it says determine whether the primary trig ratios, sine law or cosine law, should be used. So I think we have triangle ABC. This is 38 degrees and this is 15. So in this case here, we are going to use primary trig. That's our SOHCAHTOA. And in this case, this is our hypotenuse, this is our adjacent to the angle, this is our opposite, and so we would pick whichever one we want depending on if we're trying to find A or O. In the second example, we have J, K, and L. This is 68, this is 58, and this is 13. We don't have a right angle triangle here, so we can't use our primary trig ratios. So we're going to be looking at one of the other ones. In this case, we can use the sine law. And I know you may be saying, well, we don't have that pair of information, but we very easily can get that. So 68 and 58, we can subtract that from 180, and we can figure out what K is. And now we do have K, angle K, and its opposite side, and so we can just use our sine law to solve for this. If we didn't, we'd have to go to our cosine law. All right, example number 2. So example number 2 here. Alan is building a roof. I don't know if you can see this here. Hopefully you have it though. Alan is building a roof, or Alan's building a house, and he needs to know the information about the roof's design. The base of the roof is 12.8 meters wide. The rafters form angles of 48 and 44 degrees respectively to the horizontal. How long to the nearest tenth of a meter is each rafter? So our first strategy is always to draw the diagram. We know the base of the roof here is, and I'm just going to call this triangle A, B, and C. So we know side A, side B, side C. We know the base of this roof is 12.8. And it tells us that we have angles. The first set of rafters here are 48 degrees. These ones are 44 degrees. If you do the opposite, no big deal. Your B and C will be different lengths, but you're gonna get the same, it's just gonna be a mirror image solution. All right, so it wants us to find out how long this rafter is and how long this rafter is. First of all, I'm gonna use our 180 rule. 180 interior degrees, so 180 minus 48 and minus 44, take it from here to here, and I believe we have 88. Now, I'm not going to use SOHCAHTOA. I don't have a right angle triangle here, so I'm going to have to use either our sine law or our cosine law. In this case, I do have a pair of information here. I do have my angle A, my side A, so I'm going to use the sine law. And let's figure out B first. So we'll figure out the length of B. So sine B over B is equal to sine A over A. Sine B is 48. So we have sine 48. We don't know what B is. Sine A is 88, and A is 12.8. Sine 48 is 0.7431, and that's over B. Sine 88 is 0.9994, and that's over 12.8. Reminder, we are rounding these to 4 decimal places. And another big reminder, make sure your calculator is in degree mode. Cross multiply, and we get B times 0.9994, and that's equal to 12.8 times 0.7431. 12.8 times this gives us 9.5117, And I'm going to move this over. This is b times that. So on the other side of the equal sign, it becomes a divided by, and we get a value of 9.5. So we know that this rafter is 9.5 meters long. All right, let's now solve for C. So sine C over C is equal to, I'm just going to use sine A again, over A. Sine C is 44, and we don't know what C is. Sine A, 0.9994 over 12.8, just taken right from there. Cross multiply. Is equal to sine 44, and sine 44 is 0.6947, and we'll times that by 12.8. 0.6947 times 12.8 is, I believe, 8.8917. Having a hard time reading my own writing here. And when I bring this times 0.9994 over, it becomes divided by 0.9994. And we get 8.9. So there you go, ladies and gentlemen. We have solved for both B and C, our lengths. All right, example number 3 here. Fran is running a cross-country race. In the first part of the race, she runs 2.3 kilometers to checkpoint A. She turns 68 degrees and runs to checkpoint B, which is 2.5 kilometers away. And then the final turn leads back to the starting point. So she's running in a triangle. Imagine that. So first of all, A, what is the distance from B to the finish line? And the second part of this question is find the remaining angles in the triangle. So let's do this. First of all, let's draw ourselves a diagram of this. So we have the starting point. We know she runs 2.3 kilometers to checkpoint A. Our checkpoint A, she turns 68 degrees. She runs 2.5 kilometers to checkpoint B. And there we go. So we have a non-right angle triangle, so we're not going to use our primary trig, no SOHCAHTOA for this. We do have, I don't have a pair of information either because I don't know what A is, I don't know what S is, and we do have B, but I don't know angle B. And sorry, we do know S, but we don't know angle S. So I don't have a pair. So I can't use our sine law. We're going to go right to our cosine law. And half a trig is just being able to very quickly decide which of the formulas you're going to use. That comes with practice. So let's find side A here. So we have A squared equals B squared plus C squared minus 2BC cosine A. A squared is equal to 2.3 squared plus 2.5 squared minus 2, 2.3, 2.5 cosine, and that's 68. A squared is 5.29 plus 6.25 minus 4.3080, which simplified is 7.232. And that's A squared. We, of course, want A, so we're going to get the root of that. And I get 2.69. I think the question asks to the nearest tenth of a kilometer. So the 9 rounds this up to a 7. So we know we have 2.7. That answer also looks right in that 2.3, 2.5, and 2.7 is a very plausible answer. If I got an answer 27, that's not possible. So without redoing the work, I can do a quick little check just to make sure if our answer that we found makes sense. All right, let's find this angle right here. So that's because we're finding an angle, we're going to be using our cosine as well, but we're going to be using the reworked version. So to find angle S, we'll use our cosine S, which is equal to a squared plus b squared minus s squared, all over 2ab. Cosine S is 2.7 squared plus 2.3 squared minus 2.5 squared. Hands cramping up. Cosine S is 7.29 plus 5.29 minus 6.25, and that's all over 12.42. Simplifying the top, I get 6.33 divided by 12.42. Cosine S is 0.5097. Rounded to 4 decimal places. S would be the inverse function of cosine. And we get 59 degrees. 59 degrees. In order to get B, we can use our formula again, or we can just do it more easily. And we'll use our 180 rule, minus 68 degrees, minus 59 degrees, and we get 53 degrees. So we've solved the entire triangle. We have all 3 sides, we have all 3 angles, and I think we're done. That's it. Good luck, ladies and gentlemen, with your homework. If you have any questions, please make sure that you send me a message. Have a good day.